Welcome to Wildcat Science with Mrs. Haugo. This is Physical Science, Chapter 1, Forces, and we are on the section 1.6, Friction and Weight. So hopefully you are done with your questions, number 6, 7, 8, and as I told you, we're going to be coming back to our 1.4 experiment and our 1.5 experiment. So that brings us to our questions on 1.6, starting with number 12. So for number 12, for identical surfaces, how does the force of friction depend on the weight of the object you are trying to move? So referring to our graph on page 15, when the weight increases, what happens to the force of friction? So for number 12, please use a race answer, restating the answer in the question, and tell me how the force of friction would change if the weight increased. Okay, then moving on to number 13. What is the coefficient of friction for the surfaces used to produce data in table 1.3? And so you know that the coefficient of friction equals the force of friction divided by weight. So we write our equation there. And then we sub in our numbers. And the table 1.3 was used to make the graph. So let's look at that graph again. So if you remember, the coefficient of friction is the slope on a friction versus weight graph. So you'll want to pick a spot on the graph that is nice and easy to read. Perhaps where the orange line goes through a corner, and then you'll want to find your force of friction and your weight, and you'll want to sub in the force of friction here and your weight here, divide those to get your answer, and then you write it in a race sentence. The coefficient of friction is, and just a reminder, newtons is the unit for friction, newtons is the unit for weight. So they cancel out and you have a pure number with no unit. Okay, hopefully you have your question Google document open and you're working through these as we go. So moving on to number 14. Why do some motorists keep sand in the trunk of their car for winter driving? So some hints for number 14 are, we know sand could do one of two things. It could change the type of surface, which will change the coefficient of friction, which we know affects the amount of friction needed. Or if you have a lot of sand in the trunk, it could change the weight, and we know that the force of friction is affected by weight. So those are a couple of hints to help you with your answer for number 14. And remember to have a race answer and explain it in a complete sentence, please. Okay, that brings us to our last question. Use the graph in figure 1.9 to answer the following questions. What would be the frictional force on the short block if its total weight equaled the weight of the long block? Well, let's take a look at our table and our graph. So if we look here, the total weight of the long block was 5.05 newtons. Okay, so then we go to our graph and we find 5.05 newtons. So each one of these little divisions is 0.2, and so 0.05 would be a quarter of the way between these, so just a little bit to the right of 5. So we go a little bit to the right of 5, and then we would go over and read our answer in the force of friction. And you want to make sure that you get a exact answer, a precise answer to the nearest tenth of a newton. So then we'll answer it in A. The frictional force on the short block would be, and make sure to have a full sentence and units. B. Compare this force with the one measured on the long block in table 1.3. So then you'll want to go to table 1.3 and find the force of friction on the long block and compare those. So in B, compare this force from A to the one we just looked up in table 1.3. So what are they? Are they similar? Are they different? So please use a complete sentence. And then C, are you surprised by your answer to part B? Explain. So if they're similar, did you expect them to be similar? And if they're different, did you expect them to be different, or vice versa? So please use a complete sentence and explain. And that brings us to the end of our 1.6 unit. And the next unit we'll be doing 1.7. All right, see you then. Bye.